more than happy. Even I have given a few hacks even because long time ago that we don't need. So no, life as usual, as strange ways. The same for you or no? It's a bit weird. Yeah. It's supposed to be. Before Christmas, I made a tool starting in Spain. I went to Murcia, Barcelona, Lisbon, and Heidelberg.
Hello, welcome everyone. It's time to get started. It's one of the first meetings we will have in this context with both on-site and remote participation. So please bear with us as we learn also through this process. Jérôme and myself, co-chair, we are participating remotely, and we have so-called local backup, Diego Lopez, which you can see in the room sitting next to the screen. So in case there is some issues or we need to handle anything happening in Vienna, we will rely on Diego for that. But the meeting will happen in Mexico. See that everyone is connected here. We will use the queue from Mexico, so and we will synchronize with the queue in the room. So this is an emergency meeting for IETF 113. And we need to go through a bit of noteware slides before we go into the agenda. So intellectual property, the IETF follows the IETF intellectual property rights disclosure rules. By this, we mean that by participating in the IETF, you agree to follow IETF processes and policies. Please be aware of the different provisions that are in this slide. And if you want to have more information, you can access the link which is at the bottom of this page to have further details. For audio and video recordings, so the IETF routinely makes recordings of online and in-person meetings, including audio, video, and photographs, and publishes those recordings online. If you participate in person and choose not to wear a red "Do Not Photograph" lanyard, then you consent to appear in such recordings, and if you speak at a microphone, appear on a panel, or carry out any official duty as a member of IETF leadership, then you consent to appearing in recordings of you at that time. If you participate online and turn on your camera and or your microphone, then you consent to appear in such recordings. Privacy and code of conduct. So as a participant in or attendee to any IETF activity, you acknowledge that written, audio, video, and photographic records of meetings may be made public. Personal information that you provide to IETF will be handled in accordance with the privacy policy that you can find at the following link. As a participant or attendee, you agree to work respectfully with other participants. Please contact the Ombuds team if you have questions or concerns about this. You can find the link in the slide. And you can also refer to the two RFCs concerning code of conduct and anti-harassment procedures, which also apply to the context of the IETF. Now, a slide on the goals of the IETF. So to make it clear, the IETF conducts research. It is not a standards development organization. The IETF focuses on longer-term research issues related to the internet, while the parallel organization, the IETF, focuses on shorter-term issues of engineering and standards making. While the IETF can publish informational and experimental documents in the RFC series, its primary goal is to promote development of research collaboration and teamwork in exploring research issues related to internet protocols, application, architecture, and technology. If you want to have more information about how to participate and work within the IETF, you can access this RFC, an IETF primer for IETF participants. So thank you for your attention for this introductory slide. And now we will start officially, let's say, the content of our meeting. Just before going forward, online meeting etiquette. So be aware that this session is being recorded. Please keep your audio muted and video off when not presenting or speaking. And when speaking, please start by stating your name clearly. It's very important for the meeting minutes and for the audience. Thank you. In the slide, but also in the meeting materials, you can find some useful links to access the material of the meeting. We will be taking notes on HTalk. We are using Meetecho, and the recording of this session will be available on YouTube, the IETF channel, very soon after the session. Jerome, before I go through the agenda, anything to add on your side, or I can proceed with the agenda?
Thank you.
Okay, all good. So for today, we have a 2-hour session. We are currently, so the agenda, we are currently in the introduction and research group status. We have a couple of additional slides in this presentation. We will make a status on intent-based networking. In this session today, we will not have an in-depth technical discussion on intent-based networking, but just sharing a status. Then we have AI in for network management topic, where Jerome will give a status on the progress made on the document for research challenges in artificial intelligence for network management. The main topic of discussion for today will be network digital twins. We have provisioned enough time, we hope, to have an insightful discussion on this emerging topic. And we will have several presentations. The first one will be from Jordi and Albert about how to build a digital twin, comparing different approaches to that. We're looking forward to this presentation. Then we have also from Cheng, on behalf of the other co-authors, a presentation on the draft, on the research group draft network digital twin concepts and reference architecture. And this presentation in the slot, we want also to, as a research group, to reflect on this notion of network digital twin and what research could be associated to this topic. So the problem space, research challenges, questions, and directions. And in support to that, we have also shared on the mailing list, but also on the HTalk. We have a set of, let's say, questions to drive the discussion, and we welcome your opinion on those questions. Finally, according to the remaining time we will have, there is also another topic we would like to have input on is the evaluation of cooperating layered ASIAN architecture to include compute and data awareness, and Luis will be making this presentation. This will also serve as a reflection on the so-called class, so cooperative layered ASIAN architecture, to understand a bit what would be the further development of this topic in NMRG or beyond NMRG. Any comments from the participant on our agenda? Okay, all good. So let's continue. So in the research group status, we have a few updates on progress for documents. So in RSG poll, we have the intent-based networking intent classification. So the IRSG member needs to express their view on the document. This poll will end April 14th. So it's coming pretty soon. The next step will be to, if this is positive, to proceed towards IETF conflict review. So this is progressing towards RFC publication. The second document, is in RSG review. So this is the step just before the RSG poll. It's intent-based networking concepts and definition. This is still under progress. We received the review from the IRG member, and this is going through interactions with the co-authors to address the comments and then be able to proceed. We have also recently adopted research group document, Digital Twin Network Concepts and Reference Architecture. So we will have also more insight on this document during the technical topic later on in this session. Also, you may have seen on the mailing list, we have started a call for research group document adoption for the document Network Measurement Intent, which is one of the IBM use cases of NMRG. the call for research group adoption will end April 8th, and we welcome your insights on the, let's say, value of these documents and if it is ready to be considered as a research group document. Any comments on the status for these documents? If not, let me continue. As you may have seen in the agenda, for the topic on IBN, we will not go into in-depth technical discussion, but we wanted to show that this topic is also progressing in a number of other groups beyond IETF and IETF, and that there is more and more also standardization, open source, but also research activities on this topic. And this is just, let's say, a broad overview. It's not exhaustive, but we hope it's still important for the community in NMRG to be aware of those other activities. And some of the research group participants are already well connected to some of those activities. So we expect also to have collaborations in those contexts. So what we have for other groups and fora in the Linux Foundation, the ONAP project, where there are several IBN use cases being developed and part of the different ONAP releases. The link provided, you can see, let's say it's an overview of the different intent-based networking use cases appearing in the different releases. And by browsing on the ONAP wiki, looking for intent-based, you can find those different use cases and more details about who is involved and the exact topic. But it's interesting to see that since several years, ONAP is continuously pushing to have intent-based networking use cases also being part of the technologies developed in ONAP. In ETSI, the Zero Touch Network and Service Management ISG, and Diego has been recently appointed as a new chair of this ISG. So if you have any question on this group, you can also turn to Diego. But there are a couple of activities also in this ISG related to intent-based networking. So there is a group report 11, which targets intent-driven autonomous networks. It's a study to try to understand the different definitions, techniques, and mechanism of intent-driven aspects in relationship to zero-touch management. And this document is triggering a lot of interesting discussion. So I invite you to try to read it. It's part of an open draft. It's publicly accessible. And there is also a proposal for a proof of concept on automation of intent-based closed lead line service. So this is proposal by members of this ISG about using the ZSM specification in a specific context of intent-based closed lead line service. In the ITU, you have also a focus group on autonomous networks. And in this focus group, there are a set of activities which include use cases or POC also related to intent-based. Not all the activities are related to intent-based, but you can find a few of them. And the main document you can find is on the POC and proposal for a build-a-thon, where you can see the latest teams willing to propose activities related to that as part of the focus group activities. Finally, you have also at the TM forum, Autonomous Network Project. They have an interesting set of documents addressing specifically intent-based networking. So, for instance, IG 1253, intent in autonomous networks. You can find the latest draft. You just need, I think, to have a login on TMF to access it. But it's also part of a broader set of documents, which I will quickly show. And this is an interesting development because they have, as you see, several aspects they really want to specify in relationship to intent. So the document I was mentioning is the one here in the middle, but you see that they want also to go into more modeling aspects, different capabilities, API development, etc. And this is ongoing activities as part of this autonomous networking project, which I think is a very interesting development. More on the, say, events or research side, There are also a number of activities ongoing. Again, this is not exhaustive. This is just some information I like to share with the research group. So there is a second edition of the workshop on intent-based networking that will be in conjunction with IEEE NetSoft in June in Italy this year. And there is also a plan to have a dedicated tutorial on building use cases based on the TMF specification for intent that I just showed before. So I think this could be an interesting experience for also research group participants to really have a more practical use of intent-based networks. Also, more and more papers and special issues in the literature. Again, this is just an extract of some of the recent papers essentially published last year. As you can see, different special issues in different journals, but also some articles, either survey type of articles or dedicated approaches for a global view on intent-based networking. So I hope you find this information useful. Of course, everything is available offline if you want to have more insight on those documents. And finally, for this part of the meeting, NMRG Research Group status, future meetings, the main thing we will have upcoming will be, let's say, a series of interim dedicated meetings, especially for follow-ups on the intent-based use cases. We will have also currently discussing with some of the research group participants and beyond about proposal for dedicated interim meetings on specific topics. One is about designing, deploying, and operating distributed AIs. We have received a draft on this notion. It's also linked to the AI document. There could be also to interesting projects. So we are trying to see how to organize something meaningful proposition from the research group to have a good discussion on this topic. We will see what will come, but we try to have something before the summer on this. In the next, let's say, plenary meeting, currently, we plan to go to the next IETF, but this remains to see the feasibility. Okay, this one, we should have skipped it. And so that's it. Jérôme, I think you'd like to take over now.
Yeah, so I don't know if there is any comments or question regarding what you have presented before we continue. If not, yes, I will continue. Okay. Okay, all right. So yeah, the next item on the agenda was to give you a status about the document regarding the AI research challenge for network management. I will give you an update, and from the previous version that we was version 3. So I know that this document was here for a while. So this document, just maybe to make it clear for who are not aware, is a shared document that we worked collaboratively, but it's not. It is just a Google document actually. We thought that it was better to work on it. So approximately, well, I will say that not exactly 1 year ago, but almost 1 year ago, we decided to first freeze the challenge. The challenges where we want to document in this document actually. This was a temporary freeze because, of course, we are not saying that we will be exhaustive to have whole challenges because we may miss some of them. There will be news that came out due to some context and so, but at least we wanted to freeze it in order to really progress. And because at that time we have some bullet point per challenges, we have some idea, a lot of ideas actually, but not something very structured. So we have frozen this list, and then we have asked some particular contributors. We were quite willing to lead the effort with me to try to consolidate all the input we got regarding the different challenges. So we defined a template that you can see basically here. We try for each challenge to have some motivation, a very quick state of the art, not a big in-depth survey, but at least a quick survey regarding the challenges, and in particular to highlight what are the remaining problems, because in many cases we have already tried to use AI for the challenges. It works, it does not work well, and so on. And we try to highlight what have been the remaining problem and maybe some really recent results or orientations that we could investigate. To be honest, I think it was really quite successful because we had a lot of challenges that were well documented. So I really want to thank all the contributors, the let's say editors that helped me to put that in a more, let's say, a nice way at the time. We had let's say quite let's say detailed description of the challenges with a lot of references, and it was very good to structure a bit the ideas that we put behind the challenge. We have only two challenges what we didn't had really input was one was about the acceptability, but actually it's what I will call a meta challenges because we have some sub challenges that are also related to acceptability. I don't think this is a big issue. And one is about the human in the loop. I think we had a lot of discussions that we need to have the human integrated with AI even in our domain for network, for operating network. And we actually have not really, we did not really describe well these challenges at that time and still today. So based on that, I worked to prepare the V4 versions. I recently prepared it, to be honest. So here you have the new link. The idea of this V4 was, of course, to go over all the document and try to again consolidate it. So before, after the previous pass, we have only we have challenges which are well described, but of course it was description per challenge. So we need somehow to polish it to have something more coherent over the challenge. The objective was also starting to identify maybe some missing parts, some missing challenge that we would need to integrate. And also try to identify some key people or actions that will need to progress in the document. If we know somebody is maybe an expert in this area, maybe you should reach him to help us to elaborate the document and so on. So we try also to identify some people to help us. So this is what has been done to this V4 version. I will go a bit more into the details. So here was the initial list of challenges that we had in V3, so version 3. So maybe as you remember, we tried to categorize a bit the challenges. We have 4 criteria. One is more related to problems that relate to the AI technique itself. Saying in other words, it's when, for example, we need to really work on the algorithm of method of AI to fulfill the needs of a network management problem or challenge. We have identified a lot of problems relating to data, access to data, how to represent data in a relevant way for our needs. We have also seen that there is actually one particularity of our domain is that we also want to use, in many cases, want to use AI not only to predict some value and so on, but also to really take decision, or at least guide or help in decision or take actions. And this make a bit the focus, or let's say the constraint a bit different. And although we had a lot of discussion regarding acceptability, why we should, what would be the obstacle to use AI for, let's say, operating networks. A lot of issue. We are used to have our procedures. We cannot also we don't want to, let's say, let an AI automatically around the network and so on. So a lot of discussion, of course, a lot of we had this particular, let's say, criteria of what I call meta challenge, but I know that's not a good term. Anyway, so we have this list that you can see here are challenges from like IETF, data management, and so on. I will not go through each of them, of course. It's not the goal here. But after the reviews, what I call here the review, basically the review of from V3 to V4, is that we just observe that many of these challenges, which are the, let's say, the first column here, mostly are related to a single, let's say, main problem, or let's say criteria. Of course, for instance, can be the challenge may be somehow due to some problem regarding data, maybe AI techniques. But anyway, we thought that it was still, as you can see here, we tried to somehow evaluate each of them. It was quite very focused, and it does not really make sense to try to let's say to first the challenges to be, let's say, multi criteria. Maybe it's good just to say we focus on what is the main criteria that characterize the challenges, and we'll try to organize a bit the document regarding that. And although for the, let's say, AI for NM actions, actually it's mostly related maybe to the AI technique that will run behind it, some kind of a sub, let's say, a sub-level of the AI category. So this was our understanding after this let's say, internal review that we did, and so basically it runs into a new talk, a new table of contents that you can see here on the left and on the right side in the previous talk. So what is really important to see here is that in previous document, in the free version, we got this list of challenges, which were actually a big table where we have one row per challenges we describe. And now we just structure a bit based on the different, let's say, categories. So more related to the AI techniques that we will need that needs to be extended, to be worked on and for network management. And here you see a list of 5 problems that count basically to the challenge that you had before. One refers to the problem of how we can precisely define a network management problem to be able to find the right technique or right set of techniques we could use. I mean, AI techniques we could use to help us. One is regarding how we evaluate the performance of produced model, not only from an AI perspective, from if we include some let's say, network specific metric into the AI algorithm itself. And the other is how we can embed AI into the network, or we can use AI to really the challenge of using AI for planning actions for operating network. Another one is distributed AI. I will go back to this a bit after, because we don't have actually, we have it just as a placeholder now, but we don't have a challenge really well described here. Then we have all the things related to the data, say data-driven, but basically data-driven AI, that we need maybe specific data in our case, or we collect data. This is also a problem. It's not only on using data to get data, to extract knowledge, to share data. Maybe there is all of that now included in this part. And then we have the acceptability of AI, how we can explain what are the decision of network AI products, or we can ensure that when we have an AI prototype working in a lab environment, we can what will be the challenges not to be sure that it will work in production system, or at least have some guarantees. So now we have this new big part, 3, 4, 5 here, that basically contains all challenges. Then you can see that we keep as the main section of the sections that will describe some very, let's say, what we call difficult problems that we have in network managers that could rely on AI, not always, but at least that could be a good potential problem that we should investigate with AI. But what you can see here is that there are also some other, let's say, the structure is a bit simplified to keep really the focus on the document on the challenges itself. So, for instance, except of course what I have described now with this restriction of the challenge, we have removed some parts. We don't have any more use case parts. So to maybe to recall, it has never been an objective of this document to list some use cases and to detail some use cases, and we really insist before to not fill out this section before we are satisfied with let's say a description of challenges.
And I think for now, we could even skip this part. We don't need to have these use cases at this time. I think to have, so the idea now is more to go to a more, to reach, let's say, a first stable version. We don't need use cases. We have a lot of content that I think is really valid and very valuable. So we should keep, at least for this first stable version, our focus on the challenges itself. Anyway, we have some, let's say, when we describe challenge, we give some illustrative use case of application. Of course, it's not detailed use cases. So we still, in the document, it's not completely, let's say, theoretical. We still provide some example to highlight, to show, to explain the different challenges. So we still have some whole in line with the challenges, but not as really detailed use cases with detailed procedures and so on. It's something that we think we don't want now. And also for directional recommendations, somehow this will be a kind of a note or document. I think if you want also to really give, let's say, a very specific orientation to address this challenge or this challenge will be nice, but I think it's also will be a bit will be a loose focus of the document. So really, I want to keep the focus of the document on main scope, which is related to challenges, and maybe later we can of course add extension, but at now I think we have a lot of content that is really valuable. Okay, of course we have now an introduction that the idea is to show that the AI we cannot say we will not use AI for network management. It does not mean that we will use AI for everything in network management, but somehow it's something that we cannot avoid, that we will need to have it. And the idea is we highlight that with some, let's say, problems that very briefly, and because we have a dedicated section for that, we try also a bit to disambiguate between AI and machine learning here. The issue is that most of challenges, to be honest, were written with machine learning in mind. So personally, I try a bit to make it more generic. It's not always easy because maybe some are really still very machine learning oriented. I think it's not a problem, but at least in the introduction, try to a bit, let's say, disambiguate or see that it's not only about machine learning. There are some which are more generic challenges that can be, let's say, applied to different AI fields, or there are more, let's say, oriented to machine learning. So we try to highlight that. I think this is not we are still reviewing this part, to be honest, and I hope that we come up with a nice version there. We have the section about the difficult problems in network management. So previously we had a list of basically bullet points. We have a lot of problems that I think it was covered in the document. So everyone put bullet points. And now we try to organize a bit this difficult problem. So the idea is not to give an exhaustive list again. Here's to give some examples that we could use maybe when we describe challenge then. So we try to categorize them according to five criteria here, as you can see. For example, one is about the very large solution space. This can help to characterize a difficult problem. Some is related to uncertainty or unpredictability of what will be the environment or the context your solution will be applied. Some can be guided by the need to deliver a solution in real time, or there are problems that are really depending on data. Of course, when maybe you will need to analyze data for different problems, and maybe if I'm not personally a very fan of that, if that is about the need to be integrated human processes. I think this is not really something that comes directly from the problems you want to tackle, that you need to be integrated the human processes, just because it comes from the procedures that you have, not the problems that you want to tackle. So this is something that is more, let's say, a constraint that we had on top of let's say, our solutions. But the problems we want to achieve, for example, here we have some example then below, like computation of optimal path, classification of network traffic. If you don't need human, it should be something possible. Of course, if it's not always the case, but it's not, let's say, a constraint that comes directly to the problem to solve. Of course, now we have only two problems which are, let's say, described in a more, let's say, a textual way. We have this list of bullet points that we still have in the document. So the idea is that we will also take some other, and we'll try to detail them as well in this section. So what mostly remain, because I would say there is, the first is regarding the human in the loop challenges. You see the current description is very lightweight. It's what is in italic here. So the question is, should we keep it or should we somehow omit it in the document? Okay, as I said, the goal is not to provide a full list and exhaustive list of challenges. Somehow, so maybe the document now is the new organization for each, let's say, big category. We have a kind of introduction for each challenge related to AI technique. We have an introduction trying to give a bit the scope of this all, let's say, sub challenges. And the, let's say, human sub challenge will be part of, let's say, AI techniques probably that must integrate the human. So it can be somewhat put in the introduction. But of course, if you want them to have a more, let's say, a detailed description, we'll need somebody here in the room from others that could help us in that. From my perspective, I think we have a lot of discussions. There are a lot of content in Discrete AI, but we didn't really touch it in the document. I think it would be essential for us. So, in my opinion, we should need to a bit more describe this part as well. Of course, then you have a lot of other, let's say, editorial parts. We need to complete the introduction, conclusion, and so on. We need to clean reference and so on. So the idea is I know that I already promised a bit before to transfer these Google documents to an individual draft, something that is still in my mind, and I hope that you'll be able to have this with document corrected with everything ready for mid-May. So how to progress now? So up to now we have a lot of contributors. It was really great. We have a lot of the idea. Now I would like to go with a smaller, let's say, editorial team to be, let's say, maybe more, let's say, a focused team really working on the whole document, not only on specific challenge. To really do this, let's say, to do all the editorial parts, to add all missing elements and so on, and I think it would be very important. So as we already discussed, we cannot put all contributors out of the draft, so that we need also to restrict the list to this low number of people, and of course all contributors will be listed as contributors in acknowledgement section for sure. After the review of the document, this is a small editorial team. We will really agree on important change. We will make some change, and hopefully mid-May we'll be able to deliver a nice document that we got for review from everybody. But of course, as the link is open, if anyone is already interested to give us some comments, it's really open. So do not hesitate to already provide comments before. And yeah, that's it for me. Any comments or questions?
Jérôme?
Yes.
I have a question. If you can go back a couple of slides when you have the criteria for the network management problems. Yes, here. I like your approach. For the document itself, what do you intend to describe? Really, a series of problems? I mean, what will be the focus of this section in the document? It will be more on the criteria, or it will be more on trying to find some problems that have the different criteria C1 to C5? Just to understand, because I think the criteria are quite interesting and pretty, transverse. Finding problems that have many of the criteria, etc. We will be kind of going again into not use cases, but problem use cases, and then it becomes a bit the question which one to select to be significant or representative of network management problems.
Okay, so actually it was a bit in kind of, let's say, reverse engineering this criteria. It was based on what has been already provided in terms of problems. So yeah, the idea of using this criteria is just to help us to try to somehow have problems that fulfill different criteria, many criteria. The idea of the document, of course, is not the description of the problem itself, but if you have some problems that are used then in the challenge description, we have already actually. We have many people when they contribute to describe challenges and they give an example. For example, I assume this, blah, 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 blah. And so the idea is that we should take this example and put them in the first section and try, of course, to have this example because many examples are similar, so they are quite transversal, and try to show why these problems are very hard. And we actually, this criteria should help to understand why they are very hard. And then for each section, you can refer to this, let's say, big problem when you describe why this is a challenge. For example, I don't know, to use lightweight AI in network, for example, because we need somehow to deliver solution constraining deterministic type, so we need the AI working at lightweight. We put and so we put. So the idea is more to help us a bit to describe the problems and to really highlight that it's a hard problem. Why? Because of this criteria, and then use these problems as illustrative example, and we can refer it in challenge description. Is that clear, Laurent?
Yeah, thanks for the clarification.
Okay, thank you.
I think we have Olga in the line.
You just wanted to ask you, are you looking at it as a kind of just challenges for the greenfield, or do we have kind of some problems in regards to the integration with existing network management solutions?
Sorry, Olga, can you just repeat?
I'm just wondering, are you looking at the challenges from the perspective of the greenfield AI-based network management solutions, or do we need to add maybe the challenges that we need to integrate or augment or expand the existing network management solutions?
I think there is no, let's say, limit of challenges what we could put somewhere for network management, of course. So yes, we have challenges maybe to resolve some problems that you have already today, or maybe we want to integrate AI to solve new challenges, some new problems we have in network management, or that we know we have already. So this is not, let's say, fixed. And of course, if you need to expand it, some solution with AI, it's also kind of a challenge that we should highlight, but it must be highlighted not from, say, a single problem perspective, but more globally.
So maybe I'm just thinking, is there some criteria that is talking how to evolve the existing solutions and how to integrate the AI ML into the existing solutions?
I think this is part actually of the acceptability. Let's say acceptability main challenges, and then you can have sub challenges. Maybe this is a good sub challenge to have here, because if you had time to look at the document, I try to add this idea that we have already procedures, we have already solution. We cannot just say from today to tomorrow we change everything. We need to somehow integrate incrementally AI. This is something that I try to make it appearing in the, let's say, acceptability challenges, and then you have sub challenges. In particular, in the second one, which is AI-based product and algorithm in production system. Actually, this is how we move from let's say lab solutions to solution in a real network, let's say. And yes, there is some challenges, and we try to figure out what could be the orientation as well. Of course, I think maybe we then have questions also on so there is some session, and then we will go to digital twins. That's why I think it's also a possibility. Our research on digital twins should help to integrate AI incrementally into production system because you test it in digital twins and so on. This is something that appears as well here. So your remark is fully valid. So if you're interested by this, I mean, you can focus on this section and you can give me some feedback if you want. I will be very happy to take it to just to know if this highlight what you have said before, that how to expand existing solution with AI is an issue, and maybe this should be your focus somehow. Yeah.
Okay, thank you.
Okay. Any further questions to Jérôme before we continue with our agenda? Thank you, Jérôme, for the update. So let's the other topic now, please.
Yeah. Okay.
Will be on network digital twins, and the first presentation will be from Jordi and Albert, how to build a digital twin. Albert, you want to present? I will present, and you just tell me when to switch to the next slide. Okay?
Yeah. Okay. Okay, now we can see the slides. Okay, so I will start. So thanks for Laurent for inviting me for this talk. I hope that you find it interesting. So what we're going to talk is how you can build a digital twin, and we will compare a bunch of technologies, and we will try to understand what are the pros and the cons. So next slide, please. So this is a digital twin. I think that I don't need to describe further the concept, right? It is a digital representation of a networking infrastructure, and it has been documented already in drafts and many papers. And instead of focusing on what is a digital twin, we will focus more on how we can build it. So next slide, please. So next one. So I think that the first question we need to answer ourselves whenever we want to discuss the digital twin, and specifically when we want to discuss how to build it, is what are the inputs and the outputs? It's very hard to have a meaningful discussion on the digital twin, on the network digital twin, if we don't first of all discuss if it's a box, right? If we agree that it's a box, then it has some inputs and some outputs, and that's the very first thing we need to agree on, right? And in particular, that's a very relevant question if we want to discuss how we can build it and what are the challenges and also the use cases. So next slide, please. So in order to answer the question how we can build a digital twin, we have decided to go through for these inputs and outputs, which are, as inputs, we have the network configuration, which means this is my network topology. I have this type of queues. I have this type of scheduling policies like strict priority, or waited for queuing. I have this routing protocol. I have an overlay routing protocol with segment routing, and so on. That's the network configuration. For the traffic load is exactly what are the packets that are entering into my network, right? How many users I have, which type of traffic they send. Do they send voice over IP, video on demand, or data traffic for backup traffic, and so on. So those are the two inputs. And at the output, what we propose is that it is the resulting network performance. So if I have a network which has this particular configuration with that topology and this particular router equipment and switches and so on, and I load it with this particular traffic, this is the performance that I will get. And the performance can be measured through what will be the delay of the flows from the users, what will be the delay of the voice video on demand traffic, how many losses I will have in my network, what will be the link utilization, what will be the queue utilization, and so on. It is very important to note that we are not claiming that those are the right inputs and outputs. Those are the ones we are considering in my group to answer the question how we can build it and to see which are the challenges ahead. And they are relevant for the sake of the discussion. I think that those inputs and outputs can be challenged, and we can have a discussion on whether those are not the right ones, and maybe there are better ones. That's fine. I'm open to that. But for this presentation, let's assume that those are the inputs and outputs. So next slide, please. Then why these inputs and outputs make sense, at least to me? Because if you take a real network infrastructure and you assume it as a box also, that's super stupid what I'm going to say, okay? Because you guys are running networks and building them, but let me explain them from this angle. At the end, a network, if we assume that that's a transit network, what you have is data packets that are getting into the network and data packets that are getting out the network, right? If that's a transit network. So we have traffic going from ingress to egress. Now these traffic are packets, but at the end they can be voice traffic, video traffic, and so on. And then you have some sort of administrator, which can be a network management platform or a controller, which is applying a configuration to the network, okay? Or the network is already configured. The configuration is everything that it is, on the configuration file of each and every network device. And then if you assume that you have some sort of telemetry platform, what you have is performance metrics. So you can measure, okay, this is the delay for this type of flows, this is my queue utilization, this is my losses, this is my link utilization. Okay, so this is how we see a network. Of course, some networks consume and produce traffic. This is not shown here, but for the sake of the discussion, I think that this is a good example because this can be changed later on. So next slide. So then what a performance network digital twin is exactly the same. It's the box is representing your network infrastructure. You are applying exactly the same configuration to the performance network digital twin, exactly the same as you have in the real network. But instead of using the real traffic to test the network digital twin, you input a description of the traffic, okay? Because it's not a real network, so you don't put packets into a digital twin, but you put a description on how this packet looks like. How many flows do I have? How many voice of video on demand flows I have? Which is the rate for these video on demand flows? How many users I have? Which is the dynamic behavior, temporal behavior of the users, because maybe at night I have more traffic than during the day because that's a residential network and so on. So those are the two inputs to a network digital twin. Okay, and then the output are not the packets because we are not putting packets into the digital twin. What we are putting is a description of the traffic, and what we get is a description of what will be the performance of that network for that traffic with this particular configuration, right? So again, so it's for the network digital twin is simulating, let's say, a network which what has been configured with this configuration has this type of traffic, and then it will tell you, okay, this is the performance you will get. Okay, so next slide, please. So next one. So I don't want to discuss which are the use case of a performance digital twin. I don't think that that's the focus of this presentation, but I think that it is very hard to have a meaningful discussion on how you can build something if we don't see why that's relevant, right? So let me go super quickly over a few use cases. So basically, a performance network digital twin, it's a useful tool because if you think about any kind of automation, before an automatic system, an autonomous system decides what to do with the network, it is very important that it understands what will be the impact if I change this, right? If the autonomous system does not have a digital twin that will tell, okay, if you do this, the performance will be bad, so don't do it. It's very hard for the autonomous system to decide what to do, right? So basically, that's the main goal of a performance network digital twin. So here we have a set of use cases, but on the paper listed below, you have way more use cases. You can check them. For instance, you can, and I'm assuming here that this digital twin is deployed with a traffic telemetry platform and a network management platform, which are not easy to implement or deploy, but I'm assuming that they are already there, and that's out of the scope of my presentation. But you can answer questions such as, what if? So let's say that I'm employed in a company, I'm running the network, and my company is thinking about acquiring another company. So I can ask my network digital twin, what will be the impact on the network load if we acquire that company? If all these users are now using my network, what will be the performance of my network? What will be the link utilization? Or I can ask questions such as, okay, I have a 5G core and I have a backup 5G core, but what will be the impact in the users if one of the 5G cores fails and all the users need to be redirected to the backup one? What will be the session establishment? What will be the impact on the session establishment time and so on? Or you can ask questions such as, okay, can I support new user SLAs with exactly the same resources I do have, or do I need to buy new network equipment, or maybe I need to upgrade a link? Okay, so this is a set of use cases. You have more on the paper if you are interested. So next slide, please. Okay, so now we have at least we will build a performance network digital twin, and then we can discuss how we can build it. Okay, so next slide. So in what we have built is a performance digital twin, as I was explaining, and to be more specific, the configuration that we assume is we support topology, okay, which is the topology of the network. We're assuming a fixed network with switches and routers, which is the link capacity, which is the routing that you're using on your network, whether we support overlay routing like Service-X or MPLS or Lisp, and we support underlay routing also, like OSPF and BGP, whatever you are using there. What are the scheduling policy you are using? Any arbitrary scheduling policy will work, like strict priority, weighted fair queuing, deficit round robin, and so on. The queue length, and then other features such as ECMP, lag, and so on. I know that some of these features are very old, and our goal is to academically show that whether this can be built. Then the real features, I think it's up to discussion for people that have way more knowledge on how the industry works. Okay, and the traffic load, as I was saying, you have the traffic matrix, which is how much bandwidth I have from one ingress point to one egress point, and then also we support flows, meaning that we are assuming that the performance network digital twin will support flows, meaning that we have this amount of flows that start here and here, and then each flow has a different type of traffic, like voice over IP, video on demand, web, and so on. And we don't need that these flows are described as 5 tuple. We support any level of granularity. So for instance, flow can be from ingress to egress, or you can assume any level of granularity, and this will support it. Okay, so next slide. So now let's try to build this box with a simulator. Okay, so next slide, please. So here what we're doing is we are taking this box, okay, and this box is actually a simulator. Okay, it's running C code or whatever language you're using, and it's implemented using a simulator. So next slide. Okay, so we did that, and for that we use the OpNet++ simulator. That's a discrete event simulator. With basically a discrete event simulator, what does it simulates the propagation, transmission, and forwarding of each and every packet. And actually, the forwarding of each and every packet is what it's considered inside the simulator as a discrete event. So basically, a simulator is a code which takes all these events and goes through all of them and tries to understand what happens. Discrete event simulators are very well known in networking. There are way more discrete. OpNet is just one of them. There are the Network Simulator 2 and 3, GN3, Cisco Packet Tracer. So there are a bunch of them. But all of them, they work under the same principle, which is they simulate what happens with each and every packet. So if you take one simulator and you try to build this kind of box, you will find that the accuracy is very good. Now, what is accuracy? And this was one of the questions that Jerome was sending to the list, right? By accuracy, here I mean, if I take a real network and I apply a configuration and I load it with a certain amount of traffic and I measure in the real network what is the delay, for instance, for a particular flow, and then I do the same with a simulator, the difference between the real delay measured at the real network, and the delay measured at the simulator, that's what I call accuracy. Okay, and the error, the higher the error, the worse. The less accurate is the simulator, is the technology. So accuracy is very good in a simulator. Typically, you get perfect accuracy or almost perfect accuracy. But what about the simulation time? So next slide, please. So what happens is that although simulators are very accurate, the problem is that the time it takes for a simulator to simulate a network, it scales linearly with the amount of packets, okay, which are discrete events at the end of the simulator. And if you think about how a simulator works, this is exactly right. So for instance, just to give you an idea, 1 billion packets takes 11 hours in a quite beefy computer, and 1 billion packets is roughly equivalent to 1 minute of a single 10 gigabits per second link. Okay, so if you want to simulate 1 minute of a 10 gigabits per second link, this will take you 11 hours in a quite beefy computer. So of course, it is impractical to simulate a real network which have tens of links, which are even with higher capacity than 10 gigabits per second. It will take you weeks to do that. So although simulators are very accurate, they have a huge computational cost, and they are not practical, because any question you ask to the digital twin, it will take weeks to answer that. And actually, if you want to simulate a real network with real link capacities and real traffic, it's not even weeks, it's probably more, okay? And you are spending huge amount of computational cost. So that's why I believe that using a simulator for that is not practical. So next slide, please. Okay, now let's go to emulation. So next slide. So what is an emulator? So an emulator is, if you take a network, right? A network is, it is made, a real network, it is made out of two main components. Hardware, which typically is designed specific for networking. You have like network processors and ASICs and so on, which are designed for packet processing. And then the software, which is runs over this hardware, right? So an emulator is basically taking, and I'm sure that many of you already know that, but let me go super quickly through it. An emulator is taking only the software components of your network and running exactly the same software components, or as close as possible, but instead of on a specific hardware, on a general purpose CPU or in a cloud. Okay, so you take exactly the same software that you have on your network and you run it on a general purpose CPU. So this is basically, as you know, like a software router or a virtual network function and so on. So next slide. So if you build a network digital twin using emulation, what will happen is that you will have very poor accuracy. Because of course, the delay seen by the packets which are going through your emulated network will be way lower. So the delay will be, higher, will be way higher than in the real network, because your emulated network is extremely slow, because you are not taking advantage of the specific hardware that your network is using, right? Because basically you are running your network in a general purpose processor instead of in single purpose processor, which is what you have. So emulation will not be accurate, right? The delay that you will measure at the emulation will not be accurate with respect to the real infrastructure, okay? This does not mean that emulation has many relevant use cases. And I think that it has many relevant use cases which also are linked to other type of digital twin which are not based on performance. For instance, for training or for debugging or for testing new features. Okay, I think that emulation has a lot of value, but not to build a performance network digital twin, because it offers basically poor accuracy. So next slide, please. So now analytical models, queuing theory. So next slide. Now we take a different approach. And instead of using simulation or emulation, we try to see what happens if we try to build this box with analytical models, with equations. And for this, we use queuing theory. So basically, queuing theory represents our best available analytical tool to model networks. Okay, and I'm sure that you remember something about queuing theory probably from your grad studies. So basically, queuing theory, it models the network as a set of queues, as a series of queues, right? And connecting this set of queues is what we call network. And if you think about that, it makes sense, right? Queuing theory was pioneered. So the application of queuing theory was pioneered by Leonard Kleinrock, which is considered one of the fathers of the internet. He laid the foundational theory behind the internet, because he was a pioneer in application of queuing theory to packet switched networks in the 70s. And that's one of the reasons why ARPANET decided to go for packet switched. And this is what we have today. Okay, so next slide. So what we did was, we said, okay, now let's try to build this performance network digital twin using queuing theory. So we developed a model using queuing theory, which at the end is a set of equations, okay? And this is what we put inside the performance network digital twin. So next slide. So when you do that, what happens is that the digital twin is super fast, meaning that when you ask a question, you get an answer super quickly. Because at the end, the only thing that you need to run are a set of equations, and that's computationally very lightweight and it's very quick. What happens is that when you try to see how accurate is your queuing theory when estimating the delay, you will find that under realistic traffic models, it is not accurate at all. For instance, on the plot on the right, you have you have 3 different traffic models: autocorrelated, modulated, and multiplex. And on the y-axis, you have the error. So for modulated traffic, which I will explain what it is in a second, our queuing theory model estimates the delay with a 68% of error. Okay. So queuing theory does not work in this case, and it estimates a delay which is 68% of the real one. So it is not very accurate. Now, in this case, modulated exponentials can be understood as traffic similar to TCP because it has some autocorrelation properties and it's similar to TCP. So, for instance, queuing theory offers very poor accuracy when trying to estimate what will happen with traffic which looks like TCP, okay, which behaves like TCP. In this case, 78% of error. This is not a limitation that we discovered not at all. This is very well known in queuing theory. People working in queuing theory, they are completely aware that queuing theory only works for very synthetic traffic, but not for realistic traffic. So it is not an accurate solution for that. That's why I believe that it is not practical to build a network digital twin using queuing theory because it is not accurate under realistic traffic. Although it is very fast, as opposed to emulation and simulation, it is super fast, but not very accurate for realistic traffic. Okay, so next slide. So now let's try to use it with neural networks. Let's try to build this kind of system with neural networks. So how we can build this kind of system with a neural network? Okay, so neural networks, all of them, they require training. Okay, that's the first thing you need when you want to build something with a neural network. So let's take the example of in computer vision, which is an application we are all very aware of it. Let's say that we want to build a system that identifies pictures of animals, and it is able to tell us, okay, this picture, that's a dog, this picture, that's a cat, and so on. So the first thing you need is a training set, meaning you need a set of pictures with the label, meaning that this picture and that's a dog. I'm telling you that this picture is a dog, that's a cat. So you need the input and the output of the model, and then this is what the neural network uses for training. And then after training, then you can ask the model a question. Okay, see this picture, which you have never seen before. Now tell me if it's a dog or a cat or an elephant, and it will tell you. So in networking, we can do exactly the same thing, right? What we can do is recall that the input labels of the performance network digital twin are configuration and load. So what we will do is, and I know that that's complex, but this is the approach we are taking, is we take one network and we say, okay, if I apply this network configuration and I apply this traffic load, what the performance will get? So I get, and that's the first row of my data set, okay? So input label and output label. Then I take another row. I will take a different network configuration. I will change the topology, or I will change the segment routing configuration, or the queuing policy. I will change the traffic, and I measure what is the performance. And that's the second row of my data set. And now I need thousands of rows. That's complex and costly. I need thousands of rows. And when I have these thousands of rows, then next slide. So next slide, please. Okay, then once I have thousands of rows, I can train a neural network, okay? And I will tell it, okay, when you see this network configuration and this traffic load, that's a performance, and so on. That's training. After training, I will be able to ask the neural network, okay, now after training, which is very costly, but after training, then you have a trained model, which is very lightweight, I will be able to ask, okay, if I have this traffic load, which you have never seen in the past, and you have this network configuration, which you have never seen in the past, what will be the performance? And if I do the training correctly, and I do many other things correctly, the answer should be accurate. Okay. So next slide, please. So this is what we did, and for that we use a particular type of neural network, which are called graph neural network, which are designed to learn information which is structured as a graph. Okay, those are called graph neural network. Depending on your application in AI, you need to use a particular set of neural network architectures. Okay, if your information are pictures, you use convolutionals. If your information is like text or voice, you use recurrent. If your information is structured as a graph, which is a network basically, you use graph neural networks. Okay, so we did precisely that, and we call it ErlangNet. You have a paper also over there. And we basically, now we are implementing the performance network digital twin with a trained GNN. Okay, so we train it, and then that's the performance network digital twin. So next slide. Okay, so the first thing we tried is, okay, what happens if I ask the performance network digital twin, which is built using a GNN, what is the delay for a particular network configuration and a network which has never been seen in training? So it's a completely different network. And what we have seen is that if you train this particular model in networks which are 20 to 30 routers only, and you ask after training in inference, after training, you ask, okay, what is the performance of this network which is 10 times larger and that you have never seen in training? then the error in the worst case is 10%, okay, when estimating the delay. So it's quite remarkable accuracy. Also, the GNN is very fast. It's similar to queuing theory. So after training is very expensive, but after training, you can ask a question and the GNN will give you an answer in 100 milliseconds. And that's not unique to GNNs, that's pretty much all the neural network. And here we are using off-the-shelf computing, but if you use AI accelerators, you can drop this number to 10 milliseconds, okay? So super quick. So the trained model is very lightweight and can answer questions very, so as we can see, very accurately and also very quickly. And next slide. And finally, what we did also was to test what happens when you have realistic traffic models, not as in queuing theory, which only works with very synthetic traffic models, but when you have traffic models which are, similar to TCP or similar to voice over IP and so on. And as you can see, the accuracy is also very good in all the across the board, and the error when estimating the delay is always below 10%, and you have all the details in the paper. Now, GNNs are not free lunch, right? You need to build a data set, and that's quite complex and costly because I was saying you need to take one network and you need to start trying configurations, trying traffics, and seeing what is the performance. And this is your training set for the GNN. So next slide. Yeah, next one. So that's a table that hopefully summarizes what I said during my presentation, right? So emulation will give you poor accuracy, and it is very, very slow. So it is not practical. Simulation, the accuracy is very good, but the speed at which you will get answers is very slow. It will take hours to simulate one single link in a very beefy computer. Queuing theory, it offers poor accuracy in realistic traffic conditions, but it is very fast to get you answers. Then you have another row, which I didn't explain because of the lack of time, but we also tested other type of neural networks, which are not GNNs, and you have the information on the backup slides. But finally, what we have found is that with GNNs, you have very good accuracy, and they can give you an answer very fast. And that's it from my side. I don't know if you have any questions or comments.
We have Luis first, then Diego, then Benoit.
Thank you very much, Albert. Very, very interesting presentation. I have few questions. First, you mentioned, well, you did in this GNN simulation, a simulation, an analysis with 20-30 routers. When you comment about increasing the number of routers there, do you refer to the internals of the network, so keeping, let's say, the perimeter to certain entries, and or also to increase the number of entry routers or routers where entry traffic?
Yeah, you can multiply everything by 10 and it works.
But even
also the perimeter.
Oh, yes. The sources. Yeah. Okay. Another short question is: you mentioned that you can train and you can change the different configurations and so. But I was wondering, for instance, if you introduce new behaviors that could be, for instance, preemption in the queues. If this has not been trained before, I suppose that you will not get the proper result, right? So exactly. you need to train. Okay.
Yeah, good. So let me elaborate because that's a very good question. So GNNs will be able to provide accurate answers to different values of the input parameters. So if you have a larger topology, if you have a different routing configuration, but a new feature, like this is a new protocol which the GNN has never seen during training, then you need to retrain it.
Okay.
As an example, as an analogy, if you have a computer vision and you train it for a set of animals, and then, yes, it will identify any picture of that set of animals, even if the particular picture was not on the training set. But if there is a new animal, you need to retrain it.
Okay. And the very last question is, with this method, with these techniques, also we could have a view of jitter on, so not only delay or throughput, but also jitter.
Yeah, actually, I didn't say it, but it's loss, delay, it's per flow, loss, delay, jitter, link utilization, and queue utilization.
Okay, thank you very much.
Next is Diego, please.
Yeah. No, it was simply looking at here at these and thinking that we live in a world of composition and containers and lambdas and all the like. don't you think that probably in most cases or in most practical cases, a digital twin would be a combination of several? I mean, if you are not very much concerned about accuracy, but you want to have an approximate value, probably using, I don't know, Q theory, but for a certain part for the core, but you are going to go to very much detail in a certain part, or you want emulation, or you go to something
definitely.
like that.
Yeah, I fully agree. And delay, jitter no, but delay has this nice property which is additive, right? If you take the end-to-end delay and you want to split it in parts, and you can estimate for each part what would be delay, then you can add it up and you will get a nice estimation. Yeah, but jitter no, and losses no. Jitter and losses, you cannot divide them into parts and compute them independently. It's more complex.
Yes, will depend on the.
Yeah. But this is the kind of discussion I think it has value, right? Because when you start thinking about, okay, what is my output? What I want to do? I want to predict the delay. Then the discussion is more easier to have because we are down to the graph. And that's fine if those inputs and outputs are not the right ones. I don't think that maybe they are not the right ones. But when we have the inputs and outputs, then discussion is way easier.
So I'm Benoit Clay. So thank you very much for this presentation. I've been waiting for it for quite some time because there is quite a mix of, emulation versus simulation versus analytics, etc. So I like it very much. So, okay, the conclusion is that your graph neural network is fast. Great. Accurate? Well, maybe, because in the end, we deal with routers that have hardware limitations, that have sometimes bugs, that have their own limitation depending on how they're connected. So my message is, I'm wondering if we're not trying to solve everything with digital twin, in a sense that, okay, digital twin is like a copy of your network. Now we speak about performance network digital twin, and I'm wondering how far we could go, because, you mentioned the 4 metrics that you've got. Network utilization, well, if you put more flows in there, sure, it's easy to deduce. Then there is like delay. Delay, we could, as you mentioned, it's additive. That's a great property. So we could get it with a high level of accuracy. If we go into packet loss, well, it starts to be very hardware dependent, right? If we go with jitter, as you mentioned, that's the most complex one because, well, we cannot add it. So I actually have to test it. So I slowly arrived at the conclusion that maybe digital twin is not a tool for everything, because if we want to test performance, which is the thing that we care about, delay, packet loss, jitter, and link utilization, that's easy. I start to believe that we'll have to do it in the real network.
So I agree with you that link utilization is easy, but I cannot agree with your other statements. I'm sorry. So if that's the beauty of neural network, it's a data-driven approach. So if your real hardware device has bugs, that's fine. They will show up on the data set, and the GNN will catch up those bugs because you are training with real data from the real network. So it doesn't matter how complex the hardware is, GNN will be able to model that.
Very good. So I like that answer. Now the fact is that you need to have the data set out of the router.
Yes, and that I agree with you.
And you mentioned it's expensive.
Yeah, that's expensive. Yeah, that's expensive.
And so in your diagram, you were showing that you wanted to have all packets, all packet headers, basically, right?
You need to, as if you want to build this one, you need like configuration, a description of the traffic load, and then you need to measure the per flow delay, jitter, and losses. Yeah.
Right. So this is what will be, as you call, expensive. Because it's a prerequisite to enter into this last line, which is fast. I agree, and you convince me it could be good.
Yeah, yeah. I fully agree. So can I say something, because I think that you put a very good question. That's why we make such a big effort into building models that are able to be trained on small networks and operate in very large networks. Because what we believe is the commercial solution to the problem that you're putting is, okay, let's say I'm a vendor. I cannot go to AT&T's network and ask them, okay, I need a data set. Please, I need a link failure, because I need to see a link failure in my data set for the GNN to understand what happens when there is a link failure. So please throw away that link. please congest the network, because I need a data set with a congested network, because the GNN needs to see what happens when the network is congested. Okay, of course, this is crazy, right? So what we think it makes sense, but I'm open for discussion, is let's build a data set. I'm a vendor. I build a small test bed, and I generate a training set there. Like super complex training set, I can, in my test bed at the vendor lab, I can throw links, I can congest the network, and then if the GNN is properly trained and it has this nice scalability property, which GNNs have, I can use the trained model to operate in networks which are larger than the testbed. So, and then you have, like in the self-driving car model, right? When we expect to buy a self-driving car, they give you the car has been already trained. Where has been trained? Well, in towns which are, I don't know, in Nevada, and they are facilities at the. See my point? That's what we envision.
That would works for single domain, single vendor type of environment.
Yeah.
I'm wondering, I like your conclusions. What I would need, and I know it's a difficult question, but getting all data sets, it's like the starting point for any data scientist, and it's difficult.
Yeah.
What would be good is what kind of accuracy if you get like flows with sample data. And if you get a little bit of delay, but not everything, and trying to see how far we could, get into the good and fast, but with some data.
Yeah.
And this is where I'm trying to match the two, because right now, with the small amount of data we could get from networks today, that's a fact, except flows, right?
Yeah.
Then we're stuck to, let me try it in the real.
Yeah, I agree.
network.
Because so far, because we are in a lab, we can assume, we generate as much data as we want, and we don't care, and we pay the cost because it's an academic exercise. But in reality, I think it's very important to see actually how much data I do need from that test bed and how accurate it will be depending on the data. And because you are making also a very valid point, there is a new trend in AI, which is coined by the Stanford professor Andrew Ng, which is called data-centric AI. And what he says is, look, it's not about the algorithms anymore. We have the algorithms. It's about the data, okay? But it's not about, I have billions of data. It's which is the minimum set of data you need to train a model. And that is called data-centric AI. And actually, we have a challenge on the, I will send it to the mailing list. We have a challenge on precisely what you said. It's data-centric AI for network digital twin. So, which is the minimum set of data you need to generate from a network in order to have this fantastic accuracy? And that's a question we don't know yet.
Okay, Albert, so we are getting a bit over schedule. We have two questions pending. We have a comment in the chat from Zaid. So I will bring it to the audio here. So training a neural network to recognize a cat is dealing with a finite data set. Network traffic pattern is not finite. How will this solution deal with that?
I didn't. Can you repeat the question, please?
Yeah. So if you want to train a neural network, for instance, to recognize animals, it's a finite data set.
Yes.
Okay. So Zaid mentioned that network traffic patterns are not finite. How will this solution deal with that?
So they are not finite, but they can be characterized by features. And the features, they have values from 0 to 1, let's say. And I agree, they are infinite numbers between 0 to 1. But neural networks, what they do is, if you show them the feature at value 0, 0, 20, 0, 5, 0, 75, and 1, it will interpolate what happens in the middle. So the key answer to this question, which is, again, it's true in machine learning, is that you need to represent your data with features, and you need to show in the training set different values for those features.
Yeah, I think it also relates to the question from Luis that if you have new mechanism or protocols, you will need to retrain the network to deal with this new capacity. Yeah.
So if there is a new traffic model which you cannot describe with the features you have created, then you need to retrain it. Yeah, I agree.
Okay, so I have one question, and I think we have Cheng in the queue. We need to speed up a bit. In fact, I have many questions, but I will just use one. You mentioned that you for instance, you were training over a limited set of nodes, and you were trying to say, okay, how it applies to to networks that are bigger. My question is that have you tried to assess the sensitivity of the neural network if there are changes in the properties of the topology? You see, for instance, if you have a change in connectivity degree, or you go to mesh, to rings, or different types of the topology changes. Have you seen sensitivity to that?
Yeah, very good question also. So this is not our work again. This is a standard GNNs. What the math, what they tell you is that GNNs will be able to provide good accuracy as long as the distribution of the graph that they have seen in training is similar to the distribution of the graph that they seen during inference in operation. Which means that if you want to have good accuracy in ring topologies, you need to include ring topologies into your data set, into your training set. If you want to have good accuracy with a scale graph topologies, you need to have those in training. So everything goes down to what you put in training. It's the most important question, actually. Yes, so I agree. You need to show this kind of topologies. Yes.
Okay, thanks a lot, Albert. We have Cheng in the queue. Cheng, do you have a question for Albert, or are you in the queue for the next presentation?
Oh, yes. So before I start my presentation, can I ask one more question?
Yes, please.
Okay. This question is also about the data set. So can I know the scale or how large the data set is in your GNN test? And what's the cost to build the data set, to label the data set?
Yeah, so the data set, just to give you an idea, it has 100,000 rows. And each row is one network configuration, one traffic load, and the performance. And each row, it's a huge matrix because it's a configuration for all the nodes, all the flows, and we have 100,000 rows. So it's very large. And that's why we have this challenge that we organize along with I2T, which is, okay, which is the minimum data set that you can produce to have fantastic accuracy.
Okay, since your model includes the parameter of the configuration, so whenever a specific parameter is changed, you need to retrain the model. Is that correct?
Yes. No, you don't need to. So you don't need to retrain it. If you change the routing configuration, that's fine. You will get good performance.
Okay, thank you.
Okay, thank you. Thank you so much.
Okay, so Cheng, you can start your presentation, please. If you can try to be quick, it would be appreciated. Thank you.
Okay, I will try to be as quick as possible. Hi, chairs and everyone. This is Chen from China Mobile. Today, I will present the draft update of digital twin network concept and the reference architecture on behalf of our co-authors. Next slide, please. Okay, the scope of the draft includes to present an overview of the concept of a digital twin network and to provide the basic definitions and the schedule reference architecture and to identify use cases and the discussion benefits and the key challenges of the technology. The objectives of the draft includes to promote the widely adopted digital twin concepts and to establish a reference architecture and to identify future technical research directions on enabling technologies. Next slide, please. Okay, after several updates and discussions in group, the draft called for adoption in December 2022, and the draft was adopted by RG weeks ago. And in the review cycle, we received more than 50 valuable comments. And here, we must say thanks to emerging experts to help improve the draft. They are Daniel, Qiu Fang, Lauren, Jeremy, Judy, Louis, Alex, Qiao, Armin, Pedro, Wei, Zhongpeng Peng, and thank you very much. And we just uploaded the RG version -0 days ago, and the most comments were just in this version. Next, please. Okay, this table shows a summary on the comments we received and the actions we have taken. We have addressed most comments while either explaining in the mailing list or revising in the new version. Time limited, so I will not describe them in detail. Next slide, please. Okay, this slide shows the major changes we made in the new version, and include better structure the content, strengthen the research background, and more focus on the challenges, and close some old issues and focus on some new future research directions. Next, please. Okay, for the remaining other issues, this table shows the five of them. One is should a new section of enabled technology be added. Second is the recommendation to describe recent IETF technology. The third is to go deep into one or two use cases. And the fourth is to study mentioned earlier techniques related to digital twin network. And the fifth is which level of detail should the document to include without losing its purpose, especially for challenging and enabling technology sections. And all the issues we have opened in the mailing list for comment. Next, please. Okay, from this slide on, I will take time to discuss some open items regarding DT network. They are motivation, challenges, architecture, enabling technology, and research directions respectively. Next, please. Firstly, what's the motivations and the requirements for DT network? We summarize the 4 challenges in network operation and maintenance. Firstly, new network services emerging endlessly, and the network scale continues to expand. Secondly, the complexity of network OM is becoming higher. Thirdly, innovative technology need longer time to deploy. And fourthly, network optimization has a high cost and high risk due to vulnerable production environment. And to address these challenges, we can see new network automation and autonomous operation are becoming a new vision. And recently, IBM intent-based networking, auto-driving network, ADN, zero-touch network are being studied. And we can also see AI, machine learning technologies are widely used in network field to help achieve this vision. And now with digital twin here, we can see that it brings a new chance to meet these challenges. Virtual real mapping and interaction brings a solution beyond the physical network, and network digital twin can help physical network to realize low-cost trial, intelligent decision-making, efficient innovation, and predictive maintenance. Next, please. Then, what are challenges to build DT network? First, according to a cited paper here, the main challenge is to build and maintain digital twins in industrial field can be summarized as 5 aspects. They are data acquisition and processing, high fidelity modeling, real-time two-way connection between the virtual and the real twins, unified development platform and tools, environmental coupling technologies. And the network field has its own characteristics such as a higher level of digitalization, multiple services, and complex system. So we think that we summarize here 5 challenges to build a DT network. There are large-scale challenges, interoperability, data modeling difficulties, real-time requirements, and security risks. Of course, here we drop to welcome any other input on challenges, if any. Next, please. Let's quickly go through the reference architecture we recommended in the draft. In the 3-layer architecture, the top layer, lowest layer is physical network, top layer is the network application, the intermediate layer is the network digital twin, which is core part of the system. And an optional sublayer was added, can be added for data collection and change control functionalities. Next, please. Based on the reference architecture we provided above, we recommend 5 enabling technology to build a digital twin system. First is data collection, including diverse existing tools. For example, SMP, netconf telemetry, in-band network, in-band telemetry, etc. Innovative new tools, for example, sketch-based measurement and semantic aggregation mechanism for data integration and action translation. The second technology is for data storage and services. It's more of IT technologies. And the third is network modeling, which is the most important one. And for small-scale network, we think that network simulated tools, for example, OS2, GNS3, or virtualized tools can be an option. And for large-scale network, local solutions normally based on formal methods or mathematical methods, including what Judy has just described for GNN queuing theory, neural network. Yeah, and we think that machine learning AI can be used to build complex function models in twin entity. And the fourth is visualization. It is to display the network topology, operational status, and also to interactive visualization to show better understanding and to help deduce and explore the network, the interfaces and protocols for users. Finally, is the interfaces to ensure the interoperability or compatibility of the system. Next, please. This slide shows a case study on data collection. It is an efficient data collection method for digital twin network. And we know current collection method just collect raw and forward data from physical network and have problems of time cost, insufficient storage resource, low computational efficiency, and waste of bandwidth. And this draft or this method proposes an efficient and lightweight data collection, aggregation, and correlation method. For more details, we can see the draft we uploaded in NMRG data chapter. Next, please. This slide shows another case study on network modeling. It is a knowledge graph-based construction method for digital twin network. In this solution, digital twin network system design refer to the architecture in this chapter, and the base model in the solution are built via formal methods. Network device models are built based on the 6-tuple ontology, and topology models are built using knowledge graph. And function based on that, function models can be built using AI and machine learning algorithms. For more details, you can find it in our short paper. Next, please. Okay, here we want to propose some future candidate research directions. Some of them are not limited to this chapter. First, we think that we need to go deeper for the 5 key technologies listed above. Next is that we should get more measurement to quantify the gain brought by DTN to network management. And next are how AI, machine learning, RDL algorithm used for network modeling, and how can knowledge be injected to network digital twin to help achieve vision of autonomous network, and how can digital twin network integrate and evolve with legacy network management system. And finally, we need to define capability levels and evaluation methods for DT network. For instance, the resource requirement and the effectiveness evaluation of a DT system, and the metrics and the measurements to evaluate the accuracy and the fidelity of a digital twin. Next, please. Going forward, we are to issue threads for each of the candidate research directions, and to record the record the outcome of these threats as appropriate. And we also welcome proposals to enhance the document. And your comments are always welcome. That's all. Thank you.
Thank you, Sheng, for being efficient in the presentation. We have maybe opportunity to have a question on the updates and the directions set by the author of this draft, of this activity. So if not, thanks, Sheng. Let's use a bit of time now to continue on this topic of network digital twin. I think we had two good presentations. Already in the discussion with Albert and the question, I think we started to touch on a few good points. So what we wanted to have also is, again, in this notion of a research activity, exploring a new aspect. Let me share quickly something. So we had a set of questions. Okay, I hope you can see it. Let me know if it's big enough. So this was shared on the mailing list and also here on the HDoc. The idea was to really for the research group, and in general, it can be beyond NMRG, but to try to think more what it means, network digital twin, what are the research directions, research challenges that appears. And so Jérôme and myself, we drafted a first set of questions. Of course, this is open to anyone in the group to add questions and, of course, to provide your views and opinion on the already existing questions. So, Jérôme, how would you like to proceed? Do we go through the questions? Do we open the floor for inputs if there are already people willing to comment on any of those?
I think let's open the floor for people if they want to give some feedback. I think we don't have time to go each question by question, so I think it's more if you can go as people want over the question if they want to comment some of them and so on.
Okay, so if you have any inputs on that, please put yourself in the queue. Yes, Jérôme, please.
Like I can start maybe. So I think we had a lot of already some discussion before with Albert talk on this point, but regarding although the accuracy of a model that you want to use for digital twin and the data that you have as input. My question is that okay, I want to have a digital twin to evaluate, for example, performance metric or whatever metrics. But the interpretation of this metric and the, let's say, usefulness of this metric may really depend on the let's say maybe scenario of application. For example, if we have performance metrics that is about the latency, maybe you don't want knowing exactly what will be the the latency from purely metric point of view, but more on the application that you may have at the end. The latency will be used maybe to add resources or whatever and so on. And my question is a digital twin, because we have to retrain digital twin for each when we have new, let's say, maybe type of data or feature, as Albert said, using Gen, and I mean here, but if you want to use for like this kind of approach, we can ensure that we have enough cases to really have a representative model for digital twin, because okay, you can evaluate accuracy, but it's maybe very focused on the kind of metric or accuracy or use cases. But if you want to promote the digital twin to be used for more, actually to ask more questions, even if on the same kind of performance or security or whatever, same kind of question, but really depend on where it will be used. Does it mean that we can ensure that the model we use, whatever the model actually it is, the model we use will be enough accurate? I don't think Albert presented different models with different, let's say, advantages and drawbacks. And would that the case that the models that we need somehow, in my opinion, it's not we should need one single model. Maybe we need to some couple different models as well. And this is my that's not there is not single, let's say, models that will fit all, that for sure. Even in a simple use case, I think we have to think that models could be combined. And yeah, that's really my point. And yeah, we also assume that we can have data. I think something that has been said, we can have data, and I think which is very interesting here, also than the presentation regarding the architecture, is that even if we know that we have data that could be used, is how we can ensure that we collect the right data at the right time to basically evaluate the output of any digital twin. I think this is really important as well. And that's all for my first comment, actually.
Okay, thank you, Jerome. Let's try to have it as a, let's say, as a group discussion. I see that Albert is also waiting at the mic. Albert, you can speak if you want.
Yeah. Okay. Thanks. This is Albert Cabellos. So I feel that we have sort of a chicken and egg problem, meaning that somehow we try to be very, very general, and we try not to be narrowed down by a particular use case or by a particular model. And I understand why, because this is a research group and that's the goal of the research group. But what happens when we try to be so general is that we get lost into the forest, right? Because the discussion is very hard. All the answers are at the end, it depends, and so on. Now, when we discuss a specific network digital twin, and again, I'm not saying that the one I put in the slides is the right one. I don't know enough about networks. I have never run a network and I have never built a network, so I don't know. But what I know is that when we say, okay, that's the input and that's the output, then all these questions that I believe are relevant can be answered in a very specific way and very concrete way, right? And then suddenly very specific problems show up, like, okay, yes, you can build a performance network digital twin. Yes. Can a vendor do it? Yes, but then it will be single vendor, right? Because the vendor will not train using equipment from other vendors. And that's a real issue. And I'm into that chicken and egg problem, right? So when I try to discuss it in a very abstract way, I'm lost. When I make it too specific, then I understand that I'm being too specific. Maybe a solution to this is discussing, okay, what are the inputs and the outputs? Let's start by this. If we agree that that's a box, there are inputs and outputs. Let's try to discuss which are the relevant ones and which use cases enable different inputs and outputs, and what are the challenges when you start considering different inputs and outputs. And I'm pretty certain that there are a particular set of inputs and outputs for which maybe emulation is better than neural networks, or maybe a simulator, or maybe a queuing theory, I don't know. But it's very hard to discuss this without a specific goal in mind. And that was it.
Thank you, Albert. On the views for participants, we have maybe a couple more minutes to try to get feedback on those questions. Olga, please.
I do believe one of the core things for digital twin would be to encompass the business intent as well. You know, so on top of the information about the configuration and traffic, I do believe it is important that we understand all the business intents, including different intents for different customers, some security policies in the organization, any kind of other very high level policies that are not really configuration things. So I think that is one of the most important thing, how to connect the business intents with the digital twin. in order to be able to kind of do self-optimization, self-correction in the right way.
Thank you, Olga. I think we will take Diego as the last question for this topic because we still have one presentation to go. So Diego, please.
Okay, just a comment in the same line that what I was discussing with Albert before. From our experience, we have been trying to run, well, probably you could not call them digital twins, but something that was able to generate realistic data sets for training network control systems. And our experience is that there are two things that are essential. One is about repeatability. You have to have a strong control of the digital twin so you know what you are deploying every time. And you know where you're putting the focus, what are you interested in collecting, because a network is well, it's not infinite, but it's extremely wide and certainly a manageable field of different parameters and configurations, etc. But so you have to have a very clear view of what you want and which is your focus. So this is about repeatability and control. So you can repeat. The important thing of the digital twin is that you can execute several conditions with the control variations, and so you can derive some insights or knowledge from what you. This is one thing. The other thing is precisely the fact. Let me say that given the size of the network and the different technologies involved, etc., believing that we're going to have something that is a full twin of the network is, Jerome has said this about the close coupling between the real system and the model. Probably we had to choose, depending on the case and the focus, we had to choose to different levels of abstraction of different parts of the network, to put focus on, let's say, on security aspects, on delays induced by radio conditions or in congestion in some points, etc. And this is important as well. So I believe those are these two basic characteristics: repeatability based on control, and the possibility of applying different levels of abstraction depending on the goals of the twin run, so to say, are essential.
Thank you, Diego. So we capture that in the minutes. My proposal is that we have several questions, I think quite important, and that will require, let's say, iteration from the group participants about collecting your opinions, collecting references, inputs to this, to sustain our reflection on that. So our proposal will be to continue to develop collect answers to those questions and a bit structure, let's say, a research, a set of research questions on this as an activity for the group. Before understanding a bit better what we want or what we could do in the research group, and even if it's beyond the research group, how to approach that. So thank you to all the participants and presenters, people that made comments for this topic of network digital twin. This is not the end of the story, but just the beginning. Now we have our final presentation for today. It's on a different topic, something that is, let's say, has a quite long history in IETF, RTF, and there is some updates that Luis will present now.
So, thank you very much, Laurent. Yes, I will present this idea of class evolution. The next slide, please. So a bit of background. Class states by operating layer architecture for software-defined networking. This was a work that was previously adopted in the former SDN research group, but was moved to the independent submission stream after the dismantling of the SDNRG. It was finally released 3 years ago as an RFC, so it's publicly available. And the main proposition of this architecture was essentially to decouple the control of the services from the control of the transport network. So allowing them to evolve independently, but even despite of being separated, we propose a tighter integration among both the strata in such a way that cooperate in a programmability manner. Next, please. Next slide, please. Okay. So as an overview, so we defined the two different strata, the service stratum and the transport stratum. The purpose is clear. So the service essentially to program the service and the capabilities of the service itself. And in the case of the transport stratum, so all the functions related to connectivity, to the delivery of information between different components of the service. In each of the strata, we define 3 different planes: control plane, management plane, and resource plane. Also, the purpose is, I think, is clear. So, and again, despite of this differentiation in these 2 strata, the idea was to make them cooperative and in terms of programmability, to interact for having the full programmability end-to-end. Next slide, please. So the motivation for the evolution of this architecture that is what we are bringing today is essentially what you can see there. 2 main drivers for this. First, that the network are evolving towards a tighter integration with the purpose of integrating compute environments. So we have seen here in the IETF this week initiatives like the BOF for the computer-aware networking, also some other work in other working group in this respect, and so more and more operators are deploying these compute capabilities, but also are integrating with compute capabilities that are provided by hyperscalers, by external players, in such a way that networks are somehow transforming as a kind of fabric interconnecting compute environments. Apart from that, the network operations are starting to be complemented with AI/ML techniques, as clearly we know this from the work in NMRG. So also we've seen the need of incorporating these capabilities into in an operational manner to the existing network. So the focus of this evolution and bringing these ideas here will be on management and control. So we are not dealing with aspects about service placement and these kind of things. So we want to focus on network and management and control. So this is why we are bringing here this work. Next, please. So essentially, what the way in which I'm proposing the evolution of that former architecture would be, we keep the separation between service stratum and transport stratum. We somehow rename transport stratum to the idea of connectivity. So thinking on how to forward the information between the different parties. We introduce a new stratum, referred as compute stratum, again incorporating in this stratum the resource management and control planes. And we define a new plane applicable for all the 3 strata, which we call a learning plane, and essentially would be devoted to the handling of data that could help on the operation, leveraging on the IMML techniques that we will comment later on. So next, please. So the idea would be for the computer stratum essentially to consider all that distributed computing capabilities. And this, well, as mentioned, would contain the control management and resource planning related to the computing part. Some ideas that probably we could leverage on, there is some previous work in Alto, as mentioned before, but also some ideas of integrating compute environments at the end. And then for the learning plane, this would be responsible of collecting, processing, and sharing relevant data for each of the strata, for the service, for the connectivity, and for the compute. And the idea would be to leverage on AI/ML techniques, and maybe some interesting framework to follow would be the one in MNRG as well about artificial intelligence, and also maybe considering other outcomes from IETF, as would be the service assurance models and so for feeding all this stuff and helping on the operation of the network. So next, please. So as potential research directions that we do foresee, there were some of them in the draft, actually, the ones that in the first bullets. So some work could be maybe about communication means or interfaces between the strata and the planes, deployment scenarios, including legacy ones, so understand how this evolved architecture could fit. Potential use cases, or the link with ongoing activities in NMRG. Clearly, the intent-based activities of the artificial intelligence could have some fitting here as well. We think that would be the case. Additional research lines maybe could be explore novel architectural approaches, potentially maybe as an example, the bus architectures like the service-based architecture in 3GPP or what is called cloud-based architecture could be probably ways of evolving the architecture, essentially how we communicate between the planes. A potential line as well would be inter-domain APIs between the different strata or even within a single stratum. So further developing the ideas that we already, some of them we exposed in a previous draft also in NMRG. Exploring intent-based APIs or approaches for the learning plane specifically, so how we could activate or consume the information that could come from the learning plane, and maybe also even working on data models or even ontologies for exchanging and aggregating information that could be relevant for the operation of the system, of the network at the end. So next, please. So as next steps, we would like to set the scope of the draft aligned with the scope of NMRG. We think that this could be the proper host for this architectural evolution. So we would like to do some research in this respect. We would like also to have some feedback or well, at least to see if there is interest from the research group on some of the aspects here commented. We already received some initial feedback by Carlos and Diego that was publicly expressed in the mailing list, but also some informal feedback from Pedro and Chin that was given offline. And the idea is, with all that we could collect and the indications from the chairs to prepare a new and more detailed version for next IETF and basically understand if this could fit here or not at all. So thanks so much.
Thanks a lot, Luis, for being very efficient and conscious of the time. General comment, okay, we may have maybe more time to bring this discussion on the mailing list. A general recommendation I'd like to make, I already made it to you previously. On some aspect of this work, I see that there is a relationship with the topic investigated in the COIN research group. So I'm not saying that it should be handled only in the COIN research group, but because you put what is the scope of NMRG with respect to this work, but in your, let's say, in your iteration on this work, please consider to try to liaise with activities in COIN to understand also what they could bring to this discussion and what will fit more into the scope of COIN versus what could be the specific scope to be addressed in NMRG. You see, it's really like imagine that this is a central topic for you. What NMRG could be the good place to do something, and what could be maybe better handled in COIN or elsewhere. Just as a suggestion, of course.
Okay, thank you, Laurent.
So we have to conclude the meeting. Thank you everyone for your participation. I think it was, I appreciated the discussion we had today, especially the topic on network digital twin that was more central to our agenda today. So we try to concentrate on such topics in the future. We have a lot on the agenda, on the work stream of NMRG. So please continue the interactions. Really miss not being in Vienna, but I see people in the room. So please continue the discussion there. Continue the discussion on the mailing list, and to all authors, thank you for your investment in the work. And I see that we have a lot of future version of the draft to be flowing in the research group. So thank you, everyone. Jerome, if you have any last word of conclusions, the floor is yours.
Just want to say thank you also around. Thank you, Laurent. Also, thank you, Diego, for local backup. And yes, hope to meet you so our close future in real person. Yeah. Thank you all, and have a nice day.
Thank you. Bye-bye, everyone.
Wait 5 minutes. I need to move around the place in which I am either more right. So now I have to start a call with that. So that's yeah, no, that's the curse of the current, because in the past you could say, no, I'm not going to join you because I'm